Good morning, friends. This is Desigan, Assistant Professor, Department of Mechanical Engineering, King College of Engineering. In Computer Aided Design and Manufacturing ME 8691, in Unit 2, Geometrical Modeling, we are going to see the topic B-spline curves. So this is the syllabus. Irrelevant with that, there is lot of things available in this unit, especially the important topics are basis curves, B-spline curves, and basis surface. Other than that, the CHG, B-rep, solid modeling technique, Hermite curves are also available in this unit. So what is the objective of this unit? Objective means what we are going to conclude, what we are going to acquire the knowledge at the end of completion of this unit. So first point, what is Bezier curve and surface? We have having the clear cut information about Bezier curve and Bezier surface. The second one, how we derive the matrix format of curves, we can clearly identify after the completion of this unit. Third one is what is cubic Bezier and what is B-spline, we can easily identify at the end of the unit 1. So what is B-splines? It is explained below. So basically the B-splines are datas, that is vector oriented data that is used to define a curve. B-spline is nothing but a data that used to define a curves between 2 points. There is a starting point is there in a curve and ending point is there in a curve. So we have to use the data P1 from P1 to Pn. So starting point P1 and ending point Pn. So the data can be defined by using this B-splines. So simply B-splines is the data that is used to define a curve from starting point to end point. And it allows us to apply continuity condition, that is continuity equation for each segment. In a curve there are separate segments are there, that is 90 degree to initial phase, 90 degree to final phase, mid phase, intermediate phase, starting phase. More phases are there. The phases are further subdivided into segments. There is small segments are available. For that we have a continuity function or cubic function is there. So from the continuity function we have got for a second derivative. First derivative is nothing but differentiation of a equation. Suppose 2x square is there, we have to differentiate, we get 2x. 2x is there, we have to differentiate, we get 2. That is called a second derivative. So with the help of B-splines, the second derivative of a joint points can be obtained. For this, every surface we have to do 9 times more much of work than the regular work without these B-splines. When the B-spline curves is not available, we have to work it for 9 times to produce a work. So this is a cubic B-spline, the cubic B-spline model. In this cubic B-spline model, there is a P0 and P1, the points are there. There is a P0 and P1, the points are there. Just neglect the left diagram, just concentrate on the right diagram. In this right diagram, there is P0 and P1. In relevance with, there is P2 and P3. P2 and P3 are auxiliary points and P0 and P1 are relevant points. Okay. Next one is called blending function example. The blending function is having the convex null property. That means when a curve is there, it is having the kinematic link like P1, P2, P3, sorry, P0, P1, P2 and P3. So B-spline patches are came like this. Suppose a B-spline patch is there means it can be surrounded by 9 equivalent spline points. In this diagram you can clearly see that there is a center region, the shaded region is identified. It is covered by 9 equal amount of sizes to define wherever the functioning. Suppose the B-spline curve is a circle, it can be defined from anywhere, it can be defined from anywhere and any size. If we explain the cubic B-spline, or suppose we are going to explain a cubic B-spline means there is a data unit is there and interior points through the blending function. We have to go for a blending function. So generalized splines, other than the bending, without bending function, all the spline curves used in the B-splines are called generalizing spines. In these splines, we have knots. Knots means when the curve surface is available in prior to the main surface, we call it as knots. And non-uniform and uniform splines without bending function is called knots or generalized spines, and the interpolation points are Coxeter-Bohr points or the recursion method for the evolution. That means when 5 points are there, we have to interpolate means the recursion gives method of evaluation. The method of evaluation is came from the recursion. Recursion means interpolation or optimization of the relevant point in reference with the B-spline. Suppose a B-spline curve is there, we have to define with the 1/9 array method. We have to go for the matrix. If all the points in the matrix are almost same, we can go for optimization and reduce the 4x4 matrix into 3x3 matrix with the help of functioning compound of eigenvalues and eigenvectors. Next important thing in B-spline curves is NURBS. B-spline curves basic functional unit is called NURBS, non-uniform rational B-splines. The NURBS full form is non-uniform rational B-splines, and it have the fourth variable w2 x y z. The x y z is always it is coordinate with the another one variable, that is in some authorized textbook we call it as c, a b c, we call it as c. Whatever it may be, the variable may be named in any alphabet from 1 to 26 except x y z. And the NURBS having perspective viewing, that means there is a quadrilateral or three-dimensional views and cases for every explanation of B-spline curves. The NURBS having perspective view in 3 dimension or quadratic view is used for define the B-splines. These are all the things that is going to be happens in NURBS, and the NURBS is called basic unit of B-spline curves. When a B-spline curves is there, the basic unit is called NURBS. And B-spline curves can be easily generated with the help of proliferation. Proliferation technique is nothing but matrix multiplication technique. These are all about this B-spline basics about the B-spline curves. Remaining we will see in the next class. Thank you.